name is Dr. Esther Trufan, and in this video, I am going to demonstrate an experiment by which we can determine the speed of light. For this experiment, we're going to use a microwave as our source of electromagnetic radiation. And because for the speed of light, we need both the frequency and the wavelength of the electromagnetic radiation, let's start with the one that's easiest to find, and that is the frequency. First, we will pull out our microwave, and we're going to turn it around. And on the back, we will find the instructions that speak to us in our own language. And we're looking for what says to be the output frequency. And on this particular microwave, the output frequency is indicated as 2,450 megahertz. Now, this will need to be converted to hertz later. Next, we are ready to determine the wavelength of this electromagnetic radiation that is generated. And for that portion of the experiment, we're going to need some marshmallows. Then you can use any color marshmallow you want. White works just fine. We're going to need a plate, and because I really don't need such a large and tall fluffy marshmallows, I will cut them in half so that I can make them a little bit shorter. To indicate the spots that will be melted, I'm going to use some toothpicks, or you can use any type of marking tool that you have available. And then finally, to determine the distance between the molten spots, we're going to use a ruler at the very end. So let's get started. The first thing we're going to do is open up our microwave and remove the plate and the rotating circle. First thing we're going to do with the marshmallows is score them, separate them out, and then place a whole bunch of them on the plate so that it covers as much of the plate's surface as possible. And we want them really, really close to each other and sticking. I covered a substantial portion of this plate. Maybe there's space for one more, but not much more than that. And now I can set the leftover marshmallows to the side, and I can clean up my knife. So I know that this plate is too big for my microwave. So before I set up my experiment, I'm going to fold the edges of the plate, just like this. And this should be just the right size for the microwave. I want to make sure that there are very few, if any, empty spots. And if there are some spaces in between, I can always take some marshmallow pieces and fill up those gaps. And with that, we are ready for this to go inside the microwave. This will probably take just a couple seconds, so I will start at 30 seconds, but when I notice that the marshmallows are puffing up visibly, I'm just going to stop my experiment and pull it out. And I can see some of them really moving up, so I'm going to stop right here. And that should be enough for some of the marshmallows to melt. So I'm going to pull out a couple of my toothpicks. And then I already see this spot being all gooey. I need to find its center and stick a toothpick in it. I'm going to observe another one that is all melted and place a toothpick in the center. And if there are two spots, there will be more. So now it's just a matter of finding where the others are. There's a melted spot right here. And this is where we can stick our toothpick in there and see where we find quite a bit of give and stick a toothpick in the center. There's another one. That looks like it's melted. Let's see if we can find more. These are not melted, but they're that looks to be not the center, so we can always move things around if we find better spots. And there's a little bit of a melted area right here, so let's mark that as well. And we can touch it. This is one of those experiments where we can touch because we're essentially working with food. Now we're going to set our experiments to the side for about 5 to 10 minutes until our marshmallow solidifies once again. And then we can come back and measure the distance between all the toothpicks that we just inserted. It has been a few minutes since we completed our experiment with the marshmallows in the microwave, and our toothpicks are relatively solidly encased in this matrix of marshmallow. We're ready to record the distances between our toothpicks, and we can do that with a ruler, or if we need to, a caliper that is going to allow us to measure distances of up to 10 centimeters. So let's get started. We're going to use the centimeter side of the ruler, and we're going to measure the distance between all the neighboring toothpicks. We have 7.35, 7.05, 6.9, 5.1, 7.0, 9.0, and 6.4. These are all the distances between neighboring toothpicks, or what they are marking, which are the melted areas of the marshmallow matrix. From the average of these distances, we can calculate the wavelength of the microwave radiation, and with wavelength times frequency calculation, we can determine the speed of light based on this microwave radiation that we studied today.